What if one tiny metal fragment could reveal alien technology or collapse a UFO legend overnight? That is exactly what happened when government scientists tested a shard long rumored to come from a 1947 UFO crash. The sample had been whispered about for years as possible metamaterial. Some believers thought its strange layers could bend energy in ways human science barely understands. Claims even hinted it might help explain levitation or antigravity. But in 2024, the Pentagon's UFO office sent the material to Oak Ridge National Laboratory. The mission was simple: find out what it is, where it came from, and whether it does anything extraordinary. The answer turned out to be far less alien and far more interesting than the legend. The story begins with a small, layered specimen allegedly tied to a 1947 crash involving an unidentified craft. Over time, the sample became linked in public imagination to Roswell-style crash lore. Its chain of custody was murky, incomplete, and impossible to independently verify. That uncertainty only fueled the mystery. The sample later came into the orbit of To the Stars Academy, the group co-founded by Tom DeLonge. TTSA highlighted the piece as an unusual magnesium-zinc-bismuth material. The group said the specimen's micro-layered structure had no obvious conventional explanation. They also promoted the idea that the bismuth layers might act as a terahertz waveguide. In plain English, that would mean a structure capable of directing extremely high-frequency electromagnetic waves. In the most speculative version of the theory, those waves might somehow contribute to lift or inertial mass reduction. That is a huge claim, so the US government eventually took a closer look. A cooperative research and development agreement had already linked the sample to Army analysis efforts. Later, the All-Domain Anomaly Resolution Office, or AARO, took responsibility for a transparent scientific review. AARO was created in 2022 to investigate unidentified anomalous phenomena using data, evidence, and formal analysis. Because public interest in the sample was intense, AARO asked Oak Ridge National Laboratory to test it independently. ORNL is one of the Department of Energy's major national labs and has deep material science expertise. Researchers were asked two main questions. First, is the specimen terrestrial or non-terrestrial in origin? Second, could the bismuth layers actually function as a terahertz waveguide? To answer that, scientists used microscopy, spectroscopy, and isotope analysis. At the simplest level, they needed to know exactly what elements were in the sample. They also needed to see how those elements were arranged down to microscopic scales. If the material were truly exotic, its chemistry or isotopes might stand out from normal Earth materials. If it were engineered for unusual electromagnetic behavior, its layered structure would also matter enormously. The first surprise was that the specimen was not some unknown cosmic metal at all. It was mainly a magnesium alloy, whose major components were magnesium and zinc. Scientists also found bismuth, lead, and other trace elements inside layered bands. That composition may sound unusual, but unusual is not the same as extraterrestrial. Next came isotope testing, one of the best tools for checking where material originated. Isotopes are versions of the same element with different atomic masses. Different planetary environments can leave distinctive isotopic fingerprints. So if this shard came from outside Earth, its isotope ratios might have exposed that. Instead, the magnesium isotope data stayed within the expected range for Earth and our solar system. The sample showed some fractionation, likely from heat and manufacturing stress, but not anything alien. Lead isotopes told an even clearer story. The lead signature matched terrestrial lead compositions and was distinct from lunar or other non-terrestrial materials. In other words, the chemistry pointed home, not deep space. That alone was a major blow to the alien artifact theory. But the most famous claim was about function, not just origin. Supporters had focused on the layered bismuth structure as the possible key to a revolutionary technology. The idea centered on a terahertz waveguide. A waveguide is a structure that directs electromagnetic energy, somewhat like a tunnel for waves. Microwave ovens already use waveguide principles to move energy where it is needed. The speculative leap was that a specially engineered bismuth layer could guide terahertz radiation in a more exotic way. Some enthusiasts went further and connected that idea to levitation. ORNL tested whether the real sample matched the structure that theory would require. And this is where the claim really unraveled. The lab found that the bismuth in the specimen was not a pure single crystalline layer. Instead, the bismuth-rich bands were mixed with lead and showed amorphous and nanocrystalline features. There were also multiple bismuth layers, not the single ideal layer the hypothesis called for. According to ORNL, those features would disrupt the dielectric behavior needed for a bismuth-based terahertz waveguide. In plain language, the sample does not have the right structure to do the job believers imagined. The lab also noted that heat and mechanical stress had damaged the material. Even so, researchers said the evidence still strongly supports a terrestrial manufactured origin. Their conclusion was blunt. The material is highly unlikely to have ever functioned as a bismuth-based terahertz waveguide. That does not mean the sample is fake. It means the extraordinary claims attached to it are not supported by the physical evidence. One intriguing detail remains. ORNL said the exact intended use of the material is still undetermined. The report suggested it could plausibly come from post-World War II experimentation with lightweight magnesium alloys. That possibility fits the era when aerospace engineers were aggressively testing new materials for aircraft. So the shard may still be historically unusual, just not otherworldly. After the report, To the Stars said it still had questions and wanted further discussion with ORNL. The group argued that the published findings did not fully resolve the specimen's origin and purpose. That is where the story now lives, not as confirmed alien tech, but as a collision between speculation and lab evidence. And that tension explains why the sample continues to fascinate UFO believers and skeptics alike. For believers, it remains a tantalizing loose end in a larger crash retrieval mythology. For scientists, it is a case study in why extraordinary claims need extraordinary evidence. The bigger lesson may be that real answers come from isotope ratios, microscopy, and reproducible tests, not rumors. When labs finally looked closely, the mystery metal turned into a human-made alloy with a sensational backstory. That may sound less exciting than alien debris. But it is exactly how serious investigation should work. If a genuine extraterrestrial artifact ever shows up, studies like this are the reason we will recognize it. Until then, this famous UFO metal sample stands as one more mystery narrowed by science, not solved by hype.